and welcome to the detailing on slabs. Before we start with the detailing of the slabs, we shall understand what is the meaning of slab. So slab is a structural element or a member in a structure which transfers the load that is being carried by it to the beams if the structure is framed RC structure, or to the walls if it is a masonry structure. Okay, so we need to understand in what way the slabs will transfer the load to the beams or to the walls based on the type of the structure. Okay, so there are basically two types of slabs. Slabs are of two types: one-way slab and two-way slab. The third one is continuous slab. So this we shall not concentrate for time being. We shall skip this and we shall understand what is the difference between one-way slab and two-way slab. So let me take a plan. Okay, say this is a plan of a slab and this is my coordinate axis. This is x-axis and this is y-axis. So the span that is along the x coordinate, we call it as Lx, and this is called as Ly. That is a span along y coordinate axis. Now we need to take the ratio of Ly by Lx. If the ratio is greater than 2, then it is called as one-way slab. If Ly by Lx, that is the ratio of span along the vertical axis or y-axis to x-axis, is less than or equal to 2, then we call it as two-way slab. So what is the reason behind this? Why we call this as one-way slab and why it is called as two-way slab? So I'll take this as a reference drawing and we'll try to understand what is the one-way and two-way slab from this. Okay, suppose now if I go from this equation, that is this formula, Ly by Lx should be greater than 2. This indicates Ly is approximately greater than 2 times Lx, or it may be equal to 2 times Lx. That means this length will be greater than this. Okay, so this structure now I can modify like this, which somewhat like looks like this. So this is my Ly and this is my Lx. Okay, now whenever you see an element, if I apply a load on the element, then the load will get transferred to the nearest support. So the direction of load transfer will be like this for one-way slab. Okay, so you can now understand that the direction is only along x-axis. Okay, so this type of slab is called as one-way slab. Right? The concept here is, if the transfer of the load takes place along only one direction, that is along the shorter direction, then we call it as one-way slab because the transfer is along only one direction. Now if I take another slab and find out that the load direction is along both the axes, okay, along x as well as along y. So here the load will get transferred in both the directions. So such type of slabs are called as two-way slabs. Now how to identify with the sketches? Suppose if you are not able to identify with this help of this formula, then looking at the support you can find out whether it is a one-way slab or a two-way slab. When you look at the plan or a drawing of a slab, usually two-way slab will look either square in shape. Okay, most of the times it is like that. So you can say that if the size is square, then the direction of load transfer will be in both x and y coordinate axis. Hence we take it as two-way slab. The other way, if you find that one of the dimension is larger than the other, then the load transfer will take place along the shorter direction as mentioned here. So such type of slab is called as one-way slab. So these are the two methods in which we identify whether it is a one-way slab or two-way slab. The first method is find out the ratio of Ly to Lx. If it is greater than 2, it is one-way slab. If it is less than or equal to 2, it is two-way slab. The other way is from the given dimensions, draw the plan Okay, and identify Lx and Ly. If the direction is along only one direction, that is along the shorter span, then it is called one-way slab. If the load is traveling in both the directions, then it is a two-way slab. So this is a basic introduction about the slabs, that is one-way slab and two-way slab. Continuous is simple, so it will be continuous over the multiple supports. So for one-way and two-way, we usually take two supports. So one is supported on this and the other is supported here, or these two. Okay, usually we consider a single panel of slab in a floor to decide whether it is one way or two way slab. While if you take the entire panels in a floor, you consider it as a continuous slab. So for time being, I am going to neglect this. I will concentrate the detailing of one way and two way slab. Okay, so this is the part wherein we have understood the type of slabs and their load carrying mechanisms. Now we shall understand how the detailing of the slab is to be considered. Okay, so I'll start with the detailing. So I will start with detailing of one-way slab. So as discussed earlier, this is what we call it as one-way slab. Okay, so I'll give this as reference. Now based on this reference, I will draw a plan. Okay, so this is my plan. Right, now my direction of the load transfer will be along shorter span, so it is like this. Okay, so this is my Lx and this is Ly. Now I will take a cross section here. Okay, so we'll take a cross section, say section A. So this section I am going to draw here again. So this is the thickness of the slab supported on either beam or a wall. Okay. Now I have discussed in the previous discussion that the load transfer takes place like this. So since the load is transferring in this direction, this is going to bend in this manner. So the bending of the slab will take place in this fashion. So in order to prevent the bending, okay, like this, I need to provide the reinforcement in this direction. So what is the conclusion here? The load transfer is in this direction, so my main reinforcement should also be in this direction. Okay, so you need to understand here the main reinforcement. This is reinforcement that is being provided. This is called as main reinforcement or main steel. Okay, so you will be providing the main steel along the direction of the load for one-way slab. Okay, the steel that is provided or the reinforcement that is provided the other direction, this is called as distribution steel. Hope it is clear the difference between the main steel and distribution steel. Main steel or main reinforcement shall be provided along the direction of the transfer of the load, that is along the shorter span. So this is my L, clear span. This is the center to center distance. So this is Lx. Okay. Understand this concept. Once again I will repeat. The load transfer will take place along the shorter direction in one-way slab. Hence the reinforcement shall be provided in the shorter direction, while the distribution steel will be perpendicular to the other direction, shorter direction, or parallel to the longer span. Okay, so when I take a cross section and have a look at the reinforcement of distribution steel, it looks like this. Okay, and this distribution steel shall be provided above the main reinforcement. So for example, so I will draw the sketch here again so that it will be clear for you to understand. So this is a support on which the slab is resting. This is a simple support slab. Okay, now in this direction the load transfer takes place. So this is the main steel and the distribution steel will be running perpendicular to the main steel. So it will be like this, the dotted fashion. I hope it is clear. Okay, now one more thing, the concept here is 50% of the bars are bent up. So this is applicable only for main reinforcement, not for the distribution steel, because bending takes place along the shorter span, main reinforcement is provided along the shorter span. You need to provide 50% bent up to take care of any stresses and shear that is going to develop in the slab. Okay, so how to provide this? So when I look on the from the plan, so this is the main steel, okay, in which you are going to provide 50% have to be bent up, means one bar that you take from one end shall run up to this point, bend up and go like this. So when I look from the section, it is looking like this. One bar is running continuously, okay, from this end, and here it is going to bend and move to the top. This is the reinforcement shall be bent up near the support. Next, the other one that is being provided here, from the other end it will run like this, it will bend up and move up. So from this end, if I come like this, up to this point it will come, it will bend up and move near the support. So this is how the reinforcement shall be provided for one-way slab. So what is this distance? This distance is L by 10 from the inner support, or if I take from the center support, this is L by 7. So we are more concentrated on this part. Okay, so how to provide the reinforcement? One bar you start from left end, move till this point. Okay, so at a distance L by 10 from the support, stop it, bend it upward at a degree of 45 and take it straight at the top. Similarly, the next bar that is laid behind this, that is this bar, it will start from here and stop at a distance of L by 10 from the support, move up at an inclination of 45 degree, then continue. Okay, so this is how the reinforcement shall be provided in the slab. So this is the main reinforcement and this shall be the distribution steel. Okay, I hope the concept is clear. Now based on this concept, we shall take a numerical example and try to provide the reinforcement details, show the bar bending schedule and find out the quantity of steel required for the detailing of one-way slab.